Yeah, I will.
Thanks.
Dear Heavenly Father, we humbly come before you this morning and give you thanks for the opportunity we have to meet together and to study more about math. We pray for that Spirit to be with us so we can be able to learn those things that we need to learn to prepare for the quizzes and exams ahead of us. We love you very much and say these things in the name of Jesus Christ. Amen.
Amen.
Okay, so we'll just go ahead and get started on the group quiz. It's pretty big today.
Mm-hmm. Well, I'm in it.
I'm ready.
So the first one, 1A, is just saying what type of graph each equation represents.
Mm-hmm.
That one seems pretty easy. The first one is a circle, right?
Yeah.
And the second one would be a parabola.
I think so.
I think so.
Cool.
An inversed parabola.
Sure. It's an inverse.
Yeah. Okay. And then, so B was the possible solutions. Okay.
So with a circle and a parabola, like, tell me if this is weird, but so I drew it like that, and that shows that there could be 4 solutions, right?
One,
Yeah.
2, 3, 4.
Okay. solve a system of equations and give the exact answers.
Are we just solving for X on these, or where are we at?
I think what we're doing, we have to solve for both x and y to find the coordinates where they meet. And so it's like the addition and substitution thing with the two equations. Okay. I got 3 different answers, and I checked it by graphing it on a calculator, and they're right. So I'm ready whenever you two are ready to share whatever we got.
Okay, I'm getting close.
So what'd you get for the first one?
For the first one, like the first coordinate or what?
Yeah, the x minus 4.
So I solved for the 3 different points where the parabola and the circle met. And so I just got x and y. So my y's from both equations equaled 0 and 5. And when I plugged in the 0, I got 4 minus the square root of 5 and 4 plus the square root of 5. And then when I plugged in the 5, I got the answer of 4 for x.
Oh, okay.
Yeah. So my coordinates are like 4 minus square root of 5, or 1.764, comma 0, and then 6.236, comma 0, and then 4, comma 5. Those are my coordinates where they meet.
Okay.
I don't know why mine were getting crazy. I think I was missing something.
These were crazy with the, after I crossed out like some x's when I was adding the equations together, I had to use the quadratic equation to find a lot of the answers.
Maybe that's what I didn't get there. Okay. So once you get it down to a trinomial, then you need to punch it into the equation.
Yeah.
So how did you set it up? What was your first line? What did it look like?
So I just wrote down the 2 equations, and then I distributed everything. So I made them into like, real equations. So what I had was, Oh goodness, let me see. Okay, so when I distributed the first equation, I got x squared minus 8x plus 16 plus y squared minus 4y plus 4 equals 9. And then I simplified that down to x squared plus y squared minus 8x minus 4y equals negative 11.
Okay.
Yeah, and then when I distributed the next one, it was negative x squared plus 8x minus y equals 11. And so when you line those up to add them together, those two equations, you can cross cancel or cross out the x squareds and the 8x's. And then that will just leave you with the equation y squared minus 5y equals 0. And then, yeah, go from there to find the y's and then plug the y's back in to get the x's.
So on your y equals negative x equation, is the negative x, does that become negative x positive 16? Because it's 4 times 4 squared.
Let me see. So what I did, I distributed that square before I distributed the negative. So I made it like y equals negative, and then in parentheses, x squared minus 8x plus 16.
Oh,
and then
okay.
I distributed that negative and changed all those signs.
Gotcha. Okay.
Yeah.
Okay. Yeah.
Okay.
Oh, yeah. That makes more sense.
Yeah.
Okay. Are we ready to move on to number 2?
Yeah, I am.
Okay. So their handcart 3 miles in 5 hours. Sarah takes an hour and a half longer to move the handcart the same distance when she is working alone than it takes John. How long does it take John to move the handcart 3 miles when doing it by himself?
Mm.
So is this like x plus 1.5 plus y equals 3.5, or what is this?
Something like that.
Yeah.
So we have to come up with a system of 2 equations.
Mhm.
So is the first one just x plus y equals, or wait,
It's equal to 3 miles in 5 hours.
so how do we distinguish the 3 miles in 5 hours?
Mm.
3 miles, 5 hours.
Would one of the equations just be, I'm just saying, if x equals Sarah and y equals John, would one of the equations be x equals 1.5y? Because as long as John takes and then times 1.5 equals what Sarah does.
I think so, yeah. Because you'd have to times the 1.5 to his time.
Yeah.
To equal John's y, right? So, yeah, x plus 1.5 equals y.
So the other equation, I mean, if we're just working with time, then do we even need the miles?
That's what I'm wondering. Do those
Yeah.
variables drop off?
Because like, would it be x plus y equals 5 for the other equation, or is that seems kind of wrong to me, but I don't know.
Because they're only giving us hours for Sarah for the other equation, so
Yeah.
Yeah, and we're just trying to find how long it takes.
Yeah.
so we
So
drop
yeah,
off
I
the,
don't think we have to use the miles.
Yeah.
Because everything is based off of the 3 miles.
Okay. So would it be just then x plus y equals 5 hours?
I think so.
And then,
That's what I'm looking at. But
yeah. And then if we rearrange the other equation, it would be x minus 1.5 y equals 0, just to align them.
Yeah.
x equals y minus 1.5. So then you're just doing y minus 1.5 plus y. So is it?
I got an answer, but it doesn't match the hint because it says that the hint, it will take him longer than when he works with Sarah. So that y, if it equals John, should be more than 5.
Did you get 3.25?
No,
I got 2.
I got y equals 2 as well for John.
So by substituting the x equals y minus 1.5 back into the x plus y equals 5, what'd you guys do?
I canceled out the x's and then added the y's and it would equal to 5, and then you just divide 2.5 or 5 by 2.5.
5 by 2.5. Oh, okay. So in the very beginning, you guys got x plus 1.5 equals y, and then x plus y equals 5. And then you shift it over to x equals y minus 1.5.
So for our two equations, I think what both of us did was our beginning equations was x plus y equals 5, and we all had that. But then x equals 1.5y. And then I just did x. I moved that 1.5y over and did x minus 1.5y equals 0 for the second equation.
Oh.
Yeah. But I don't think that I did it right because it's supposed to take him longer than 5 hours if he does it himself. Like the y is supposed to be bigger than 5.
So I changed the x plus 1.5 equals y into x equals y minus 1.5. And then substituted y minus 1.5 for x, and the x plus y equals 5. But I'm still coming up short, too. I'm getting like 3.25.
Yeah.
Should one of these be a multiplication instead of an add or subtract?
Maybe.
Like the 1.5, is that supposed to be?
I multiplied that to y.
Did you?
Yeah.
Okay.
Mm-hmm.
Yeah, it's like we need to find John's time and then multiply it by 1.5. I don't know.
Yeah.
So how can we solve John's time? Yeah, it will take him longer than when he works with Sarah. Yeah, so it shouldn't take him. Well, yeah, you're right. Okay.
How about this? I don't know if this is right. Oh, wait. Let me actually finish the problem first and see if it works. Where'd my calculator go? My computer feels like it's going to explode. It's so hot.
So it takes Sarah 6.5 hours to do 3 miles. Is that right?
Oh, I don't know.
Because it's an hour and a half.
It's
Or is that their alone time? She's an hour and a half longer.
Yeah, that's
John's
their own time.
That's their alone time. Okay.
Yeah.
What am I doing?
Okay, well, I think I got John's, but I just don't know how that translate into how long Sarah does. Like, I don't know if this works. But I incorporated the miles into it now. So I
Uh-huh.
x plus y equals 3/5 or 3 miles per hour.
Uh-huh.
And then again, I did the x equals 1.5 y, which I moved over to be x minus 1.5 y equals 0. And then I solved that, which gave me, well, I crossed out the x's, so I multiplied that x plus y equals 3.5, or 3 divided by 5. I multiplied all that by -1, crossed out the x's, which left me with -2.5 hours y equals 3 miles per 5 hours. And then, so I divided that 2.5 from the y, and I divided that, 3 divided by 5 divided by 2.5. And that gave me 3 miles over 12.5 hours. And so when you divide those, 3 miles per hour equals a decimal of 0.6 miles per hour. And then John's, if you do 3 divided by 12.5, it equals 0.24 miles per hour, which is slower than 0.6 miles per hour. So that means that John is slower than when he and Sarah work together. Does that make sense?
John's lazy. It does.
So, but
how
then,
long does it take him to go 3 miles?
12.5 hours instead of
12.5. And it takes Sarah an hour and a half longer to move the handcart the same distance when she is working alone than it takes John. So is she an hour and a half on top of the 12.5?
Yes.
I think so.
Right? Okay.
Yeah.
For some reason, it's confusing me.
It is confusing. Like I didn't know how to translate that back into how long it would take Sarah. So that makes sense though, Ben. Just add 1.5 hours to his time for 3 miles to get hers.
But we only need to know John's.
Yeah, we only need to know John's.
Right.
But I'm sorry if it's wrong. That's all I could come up with.
No,
Yeah,
let's see.
I followed you through that. It just, the 3/5 was clever. Yeah, that was good.
Yeah. I mean, it came out that he's slower than when they work together, so.
Right.
Yeah.
And it should be quite a bit slower, which it is.
Yeah.
Yeah.
Wonder if we get extra credit if we quoted that scripture. Like, neither is the man without the woman, nor the woman without the man, or something.
Right.
Extra credit, 2 points.
Yeah.
Yeah, I'm good with that if you guys are good with that.
Yep.
Okay.
Okay. So number 3. Oh, there's 3 more parts to number 3.
All right. The garage is 18 feet wide. The owner wants the arch to have a height of 12 inches. What is the radius of the circle?
So we're trying to find that middle line.
From center of circle to the outside of the green?
Yeah.
Yeah.
So we got 9. We just need R and Y. Okay. Nonlinear equations may be hard to consider a system of thinking about a grid behind the picture. Write a system of 2 equations with 2 unknowns, R and Y. I got a kid situation here. Hold
Okay.
on.
Maybe like another. Y equals distance from horizontal line of garage to center of the circle. Y equals the distance from horizontal line of the garage to center of the circle. So the horizontal line, is that where that 9 feet is? Like that line up there?
I think the horizontal's the 9 feet.
Okay. Oh, so this is kind of like, well, I guess we're trying to solve the triangle. Because like R is the hypotenuse and Y is something side. So wouldn't one of them be, because that's a triangle right there, would one of the equations be 9 squared plus Y squared equals R squared? Because that's a right triangle, so it's like A squared plus B squared equals C squared.
Right, yeah.
Okay. somehow we need to use that 12 inches too. So,
Yeah, I'm not sure where that fits in.
yeah. Would it be... Oh.
Would we just have to add that to the y?
Yeah, wouldn't it be just 12 plus y equals r? Because from that center of the circle, y plus 12 gets you to the outside of the circle, the green line, but
Right.
r is from the center to the green line as well. So y plus 12 equals r.
Right, yeah, so they should be the same distance.
Yeah. R. Okay. So then if you flip those around, you'd have y squared minus r squared equals 9 squared. And then y minus r equals 12. Would we, like if that's how you flip those equations away, y squared minus r squared equals 9 squared, and then y minus r equals 12, in order to, I don't, how do we make those equal? Because like you can't go r squared minus r.
Right. Would you have to plug it in? Like plug in the r equals y plus 12 into r squared, so just squared the y plus 12, and then solve it equal to the 81?
Yes, so you're saying that we would plug in the second equation into the first one.
Right.
So that would be y squared minus, in parentheses, y plus 12 squared equals 9 squared.
Mm-hmm.
That makes perfect sense. Do you want to catch Ben up what we just did?
Okay, so in the second part they have that like little diagram, and we figured out since there's a right triangle there, so we'll use Pythagorean theorem that r squared is equal to 9 squared plus y squared. And then if you look at it, r is equal to y plus 12, those because they're both the radius.
Right.
Then we're going to take the r is equal to y plus 12 and plug it in the Pythagorean theorem side and solve for y.
So it'd be y plus 12 squared equals y squared. 9 squared plus y plus 12 squared equals y squared.
We moved it over so it's 9 squared is equal to y squared minus r squared.
Okay, yeah. Yeah, that looks solid. So our two equations is the Pythagorean theorem equation and then the r equals equation.
Yeah.
And then you just solve for that. Okay.
Hey, question, Rachel. I just thought of this.
Uh-huh.
Just working in like units, because with the 9 we're working in feet. Would we have to change that 12 inches to feet? Because otherwise our units are going to be weird.
That's true.
That makes sense.
Yeah, so just switch it to 1 foot.
Okay. All right, that's going to be different. Whew.
Yeah. Good
I
catch.
got like this weird fraction, and I was like, they have to want like this whole number.
Yeah.
So it'd just be y plus 1.
Yeah.
Y squared minus r squared. Also, another question. You might have already said this, but I'm not sure. But with that Pythagorean theorem, which is 9 squared plus y squared equals r squared, when we subtract the r squared to one side and the 9 squared to the other, the new equation would be 9 squared minus r squared equals negative 9 squared.
Say that one more time.
When we did the Pythagorean theorem equation, 9 squared plus y squared equals r squared. When you subtract r squared and put it into the other side, and when you move 9 squared to the other side of the equation, the new equation be y squared minus r squared equals negative 9 squared.
Oh, yeah, you're right. It would be.
Okay. And then the other equation would then be y plus 1 equals r, or moving it around, it's y minus r equals negative 1.
Yeah.
So why do they all go on the same side?
Sorry, I guess we don't need to move that second one because we're replacing that into r. Anyways, what was that, Ben?
Why do we throw everything to the one side of the equation?
With the second one, I guess we don't have to, but the first one, we want, I guess you don't have to with that one either, because we're just replacing it.
Oh, it just depends if you're doing addition or substitution?
Yeah.
Okay, yeah.
Yeah. And with this one, since we're doing substitution, I guess you even really don't have to move anything.
I follow you.
I'm ready with an answer whenever the both of you are.
So does the 18 feet not play anything in this?
I didn't use it.
Yeah.
No, because you just use the 9 feet for the triangle.
Right. Since that's a right triangle, that's all we need, huh?
Right, yeah. Okay, I'm ready.
Yeah, go ahead. Don't let me slow you down.
I got y is equal to 40.
I also got y equals 40.
Okay.
And then plus 1 equals that r. And so r, which is what they were searching for. Yeah, what is the radius of the circle? R equals 41 feet, right?
Yeah.
Because it's r plus 1. Okay.
Yeah. And I just plugged it back into that Pythagorean theorem. 9 squared plus 40 squared equals 41 squared, and it all equals out.
Beautiful.
Perfect.
Woohoo!
Awesome. And we got our 2 equations. Perfect.
Yep.
Let me make those more visible.
Makes sense.
Okay, I think we're good.
Cool. We'll see you on Monday.
Okay, we'll see you guys then.
Couple more weeks left.
Woo!
Yeah.
Then we're done.
Finally.
See ya.
Yes.
See ya.
All right, see ya.